Good morning, everybody, and happy Pi Day. There you go. There's Jora. Hi. All right, cool. All right, we got people confirming. All right, how does work? Audio is good now. All right, we can start over. Okay, perfect. Perfect. How's everybody doing? As I said, good morning, good afternoon, good evening, wherever you are. I'm very excited to let's celebrate Pi Day a little bit with Meadow running on a Raspberry Pi. I was saying that Meadow has matured enough that it's cross-platform and in hardware and software, which is something crazy. I haven't seen that before. And so let's do a deep dive on a little bit of how, if you have a Raspberry Pi running around that are super popular, you can get to try out our stack with Meadow. And yeah, let's do IoT things with .NET. I was going to show you, let me go back here to the solo view. So I got this is a Raspberry Pi 4. And as I was saying, it's a pain to just use the male terminals on the board itself. I had to count up and down these things to make sure I got the wiring right. But I got this little shield that has like screw terminals, and also like it moves over the male pins here. But there's also nice markings here, as well with LEDs that it will show you traffic whenever you're using them. So it's great for wiring things up, and you're making sure that the pins that you're using will light up. So you should be good. So yeah, I got this off of Amazon. I think it was like 15 Canadian dollars. So might be like 12 or something in US. Anyway, highly recommended. Super useful. And yeah, without further ado, let's get going. So first thing I want to show you is, let's talk about like people are like, what? Like Meadow running on a Raspberry Pi? Like, how can that be? And we got this handy blog post that Chris Tacky wrote, but just a little bit of a breakdown of how we got to run Meadow on Raspberry Pi. And the explanation is this, basically. You can read it over in our blog post, but the gist of it is that our Meadow OS has a Meadow DLL class inside, and that DLL class starts will start the mono runtime, and then in turn will call your API, your app, to start right away. So for the developer users, all this happens under the hood, and so for the developer side, we simply expose and initialize and run methods on a Meadow application, which is, I think, most of you are familiar with. You initialize, you basically just do all you're setting up all your hardware, your sensors, your displays, and all that. And run is when the method that is like, once you're done initializing everything, then you can start doing things with the hardware that's already initialized. Now, it's a little different with the app startup on desktop. So basically what we have here is we need to jumpstart, we need to add a public static void main inside our Meadow class, because we need to explicitly call this instruction, Meadow OS start, which is the same functionality that it's what Meadow does to start the .NET runtime. So like if you see this diagram here, you can see the Meadow side, the Meadow F7 hardware. It has the Nutix, which is the real-time OS, super small on those little chips, embeddable devices. And it also comes with, we pair it with Mono. Then in turn, we have that class Meadow DLL that has the static void main inside, which in turn opens up, runs the Meadow OS and starts running the application. Whereas with Meadow Desktop, we have in our application, we explicitly call the static void main. And this will also it'll skip the instruction for the public static void main, and it'll call the OS run application, which I'll show you in a moment how that works. And that's it. That basically it's all that it's needed to run the application from a Raspberry Pi. The same goes with even running it on Windows. So if you don't have any devices, you can also run Meadow on Windows, which is also pretty handy. So yeah, in the end, it's all like, so you can try our platform. It also helps you boost development cycles without having to wait on those, those transfers on devices can take a while, especially when you're developing things like HMI screens, user interfaces. Sometimes your things is like things are off the margin or off the screen. It's really quickly if you do it just on your computer. So that's basically how it works. So we have here in our documentation here. So let me put this a little bit bigger here. Okay. So normally if we go to the developer site here, we have a section here for Meta OS, and it has a little bit of getting information about Meta OS or Meta Foundation, which we'll go over in a bit. But then the important part is going to get it started. And here's a breakdown of like, all right, pick your device of what you want to start with. So in this case, we go with Raspberry Pi, say. So we click here, and there's like my little project lab there. My little Raspberry Pi. So used to using my project lab. And it'll give you a rundown of, depending of like what way do you want to work on the Raspberry Pi. So you have the flavor of going in Visual Studio code. So this way you can actually install Visual Studio code inside your Raspberry Pi. If you have already a setup with a mouse, keyboard, a monitor, and then you can just code directly using Visual Studio inside the Raspberry Pi. But I I advise against it. I'm a .NET developer guy. It's most of people here that want to try IoT. Visual Studio is like our home, basically our home IDE. So there's this other way, which I think is more efficient, is going the Visual Studio 22 route. And this one's really cool because you can actually install an extension on Visual Studio. They call the Visual Studio Linux debugger. So this thing is pretty awesome because basically what it does is you're building up your application in your Visual Studio. And whenever you're done with your changes, you use this extension to build the application and send it over to SSH over the network to the Raspberry Pi, all the assemblies only. So that way, it'll save you time of just remoting in and try to code into your Pi, but you can just work straightly from Visual Studio. And then you can SSH into your Raspberry Pi and trigger the application to run, which makes things a lot more easier. So that's why here we added to this step about adding the Visual Studio Linux debugger. It has great documentation to show you how to use it. So basically, you got extensions, Linux debugger, and then you can build and deploy, which will feel kind of like when you're working on Meadow, that you have your application Visual Studio and then you build and deploy. It's kind of like the same deal that you're building on your computer and sending the assemblies to your device. And there is also an experimental one, which is the remote debugging. It doesn't work that well. I haven't got to work yet. So the additional step in this case, we'll need to remote in, and then we have to manually trigger the app to run it. But it's still a time saver. So there's a little bit here of plumbing that you need to do. Obviously, you have to enable SSH on your Raspberry Pi and make sure that it's connected to the network. And then you have to tell them like what is the IP address you're connecting to, and get the user and the username and password to remote in, and let the Visual Studio Linux debugger to do the communication and start transferring files. So this is a really nice way to work on Raspberry Pi. So let me show you how that works. Let's go to. I'll create a new one first, and then we'll go to our samples repo, and then we'll wire some stuff there. So if you go and you open your application, then you can look for Meadow here. And now there's a Raspberry Pi. Hello, I want to say hello Pi Day. How about that? And then to create here, So please, if you have any questions, feel free just to throw them in the chat. I'm monitoring everything. I also have moderators taking a look and they can also jump in to answer any questions. So yeah, let's see. So we have here our little Meadow Raspberry Pi application. Basically what this thing has is a reference to a NuGet package called Meta Foundation. That's our gigantic library of, I don't know, 250 drivers or so that'll let us have a plug and play experience when wiring things up. In this case, I have a time of flight distance sensor here that I want to wire, and I can show you how it works. I also have an atmospheric sensor. This is an HTU 21D. This one gives me temperature and humidity. And I also finally want to wire one of these. This is ILI 9341. This is a display that comes on that are using the Raspberry Pi, the Project Labs. And so I think let's do a little bit of wiring in there. But first, I want to show you the basics. So you have Visual Studio, you create a Raspberry Pi project here, and here's our reference to Meadow Linux, as I mentioned on the blog post. And this is the structure of the Meadow app. So if we open this, notice in the signature, we have a Linux app to specify, we have, it's no longer an F7 hardware. And we specify what kind of device here. So in this case, we're doing a Raspberry Pi. This helps us whenever we do device.pins and we have access to all the different pins that the Raspberry Pi has. So, and here we have our regular run-of-the-mill initialize and run methods, which only has a couple of console write lines with the logger. And remember, in the blog post, I mentioned about something about calling the Meadow OS start. It's right here. This is the publish static void main method that we need. And this will actually trigger the Meadow OS to load up the entire Meadow OS stack, and then in turn runs the initialize and the run methods. Okay, so let's first build this thing. Let's deploy it into our application. So, okay, so that built successfully. So if I go now to extensions, as I showed you, and I go build and deploy, this is gonna connect to SSH. I hope it works. Upload successfully, completed, perfect. There's a little console here for Linux debugger, which helps a lot. Let's remote here to have a console. That's right. Awesome. All right, so on that terminal on the left, I am connected to the Raspberry Pi remote console. So if I do ls, you can see all the things that are where I am right now. And notice that here that we have VS Linux debugger. This is the folder where all the apps that I'm using that will be transferred there. So if I go there, yes, I do the ls again, and you can see all the different apps that I've transferred over time that are all doing all my tests. So in that case, we can see the Hello Pi Day here. So let's go to there. Hello Pi Day. And finally, since we have the assemblies there, all we need to do is .NET hello Pi Day, and you run the DLL. And that's it. You can see the app runs immediately. And there's my initialize string here. And I have my run and my hello Raspberry Pi console messages here as well. So that's it. That's basically everything you need to run Raspberry Pi, just connected via SSH and using the VS Linux debugger. So yeah, this will be the way that I want to show you now. And again, feel free to ask me any questions about any of this. And another exciting thing I wanted to show you was we have a new repo of samples. Our sample department was getting really crowded with, I think, 5 or 6 repos. So it was hard to maintain. So we came up with Meadow samples. Oh, hi, Trey. Oh, thank you. Thank you very much. As I was saying, we had so many repo samples that they were hard to maintain on every release. So it was much easier if we just make a monolithic repo that had all the other samples. So we created Meadow samples, and here you can see that we basically wanted to keep the same structure for people who are already familiar with where the samples were, depending on the repo that they were. So basically, we have like a landing page of Meadow samples, and then you pick the one that you wanted to see. We have Meadow project samples. If you this is the like the first repo that we made with several project samples with links to their Hackster projects. So you can start getting when you can use your dev kit and start connecting things there. Um, there's also new ones. Well, we have the Project Lab one that we also have here with some of the new project. We have Meadow Cloud as well, connecting to examples using Meadow Cloud, wiring things up with Grove connectors and Quick connectors, things like that. And this also gave me flexibility because for Meadow, the Meadow desktop samples, I was including Windows and Linux samples. But Meadow Linux is not only for Raspberry Pis. If you also have a Linux machine, you can also run Meadow applications. You just simply don't have access to the pins unless you install you plug in an I/O expander like you do on Windows. So I made the subset of single board computer samples. So this is the one that will have things like Raspberry Pi, Jetson Nano. We also have a Seed Studio or a terminal here. There's also could be samples there. There aren't any samples there at the moment. That will be in the plans. So if I go here, then basically there's a little a little welcome message with some of the samples, and there's also the famous pinout for Raspberry Pi that I needed to use at the beginning. I also printed it out here because it's they're not marked in the silk screen, so it's a it's a nuisance trying to wire things up on this thing. But anyways, yeah, there's some samples here. We're slowly growing things. It's also this is the it's super easy to port samples as well. This is the Wi-Fi weather app that I made for Project Lab. It's basically just grabbing 95% of that code and moving it also to the Raspberry Pi. And the only thing that I needed to do was basically tweak the pins that are connected. They're obviously not the same as different hardware. So I might do more finesse on this project so I can make it do multi-targeting. So that way I'll have like a core project that has the business logic for the view and connecting to the service. And then we have sub projects for each hardware. And then you can see how it comes together when you're building applications on Windows and then you want to try your device without modifying any of the business logic. That's in the to-do. So for now, I want to show you. Let me open that sample project solution. So if you clone that repo, it'll kind of look like this. So we have a projects, what's it called? Meadow samples right here. And so if you go to source, then there's the subdirectories for every sample. So a group of samples. So if we go to the Meadow SBCs or single board computer samples, you go here. And we go to source again, here's the solution. So if we open this, let's see. All right, so here I have several projects. So yeah, I'm trying to slowly grow this solution with many projects. Is there a driver for the Raspberry Pi build hat? I'm not sure what the build hat is actually. If you could elaborate, or maybe I can look it up. Raspberry Pi build hat. Oh, I see. Does this have growth connectors? I don't know what this I don't know what these connections are. Yeah, I don't think we have them. We don't have a driver for that yet, but which by the way, that brings me to another point. We're constantly growing and we want to improve and have support for many peripherals as possible. So Meta Foundation has already a ton of drivers, but we've seen our public Slack and our community that whenever they buy some peripherals that we don't, oh, it's for Lego motors. Oh, that's cool. Yeah, I don't think we support that yet, but if you want to do some hardware requests for drivers or support, you can always go to our meadow_issues repo, and then you file an issue here. And here you can have a feature request or driver request. So that way we can also keep track on these things, and we can take a look, and then we can give an estimate of if it's a low hanging fruit, we can get it done right away. Otherwise, we'll keep slowly churning it until you keep track of this until we get it like fixed or ready for upcoming release, and then keep an eye on the releases, and we might include it sometime in the future. So yeah, it's we're constantly proactive about people coming here and giving us some requests, or everything is also open source. So if you have the bravery of trying to build it yourself, we can also help you out if you need a little bit hand of writing some drivers. We're more than welcome to help you out with that as well. All right, let's go back to this. This is the Meadow SBC samples. And I built this one last night. This one was really cool because there were some pins on the Raspberry Pi that I was having issues with. So I was slowly enabling all these pins by using the LED object, and we pass in the pins. I don't need to wire LEDs because this guy already has LEDs wired here. So, oh, I think my Droid Cam died. Hold on. Give me 1 second. Oh boy. Give me 1 second, guys. Sorry about that. Oh, that's unfortunate. Let me see. Where is... Oh, I got another cable here. Let's grab a cable because I'm going to have to wire this thing. Typical of demos. Sometimes you show things, they don't work. But I got it covered. So we go here. And USB. Hold on, I'm trying to solve the camera issue on my, there we go, start. There we go. Okay, we're live. All right, so let's put this back here. Okay, I'm good. And then I'll put this here. There we go. Okay, sorry about that. As I was saying, so I have this list of LEDs, and I'm passing each pin here. Let me zoom this in. And I can also zoom in this a little bit more so you can see better. So I have a list of LEDs, and then I'm initializing the list of LEDs, passing pins from the Raspberry Pi. Again, this is a Raspberry Pi device, so whenever I do device.pins, I have access to all its general purpose I/O pins. And so passing all these, I can get to see, because of the shield that I have here, it already has wired. It has LEDs wired in every terminal. So by just passing on the pins, it's almost like I'm wiring LEDs for all of these. I think I can actually make this sharper. There we go. And so let's see if we can run this. So I am going to exit this solo mode, and I'm back here, and I'm going to do extension, Linux debugger. Oh, first of all, I'm marking this one. You need to set up as a startup device so you can tell the extension of the VS Linux debugger. You can tell it to which application you want to send over. So build and deploy. So if we look at the outputs here, compressing, uploading, upload completed successfully. That's great. So if I go to the command prompt, I do Control-C to close this app. I'm leaving this application. So here we'll have the digital output sample. So if I do here, .NET digital DLL. So if I do that, we should see the LEDs lighting up and then turning off. So that's a good start. At least you can get to see. I figured out there are 4 pins out of the, I don't know how many are there here, that I shouldn't touch. Pins 14 and 15 are not even in the list of pins, so we need to file an issue with that. And pins 7 and 8, they throw an error for some reason. We'll need to take a look at that as well. But other than that, we have plenty of other pins that are available to try out. So without further ado, let's do something more interesting now. No more LED blinking. I know Brian doesn't like them. All right, so let's go, and I have another one. This one's cool. I have the distance meter here. So this one is using the VL53L0X. This is the time of flight sensor or distance sensor. And this guy is I2C. So it's only 4 wires that I need to connect, which is pretty handy. So let's plug this in. So I need to put this one here, and then let's put ground. I'm plugging them directly to Raspberry Pi because, again, I don't trust my breadboard. It's quite old, and so I had a lot of headaches trying to get that working. Oops. Okay, and there, and then the clock. Which one is it? Clock is the yellow one. Clock is the yellow one. So that one, it would be this one here, and data is the one next to it. There we go. I think I have everything connected properly. Let's leave it like that for now. Hi, Allison. Hi, Dominic. Welcome. All right, so I have my time of flight sensor already here, plugged in. Now let's try that. So let's mark this as a set up startup project. And extensions, we go back to build and deploy. Actually, I should also explain how this sensor works. Sorry about that. So basically, we have a NuGet package. In this case, it will be the sensor's distance VL53L0X. So you'll need to look that up onto NuGet. You add it into your project, and then what's needed to initialize it is basically just sending over an I2C bus object. So in this case, we're doing device. In this case, Raspberry Pi. We call that primitive. Sorry about that. Create I2C bus we pass in a number because the Raspberry Pi has, I think, 2 or 3 other I2C buses there. So I'm referencing the first one, which is I'm plugged in here at the top. And once I do that, then I just need to pass in this I2C object onto the driver itself. And that's pretty much it for initializing. Now it depends on how you want to use it, because we also have an updated event. So this is an event that's triggered, and whenever it gets triggered, we get a result or a reading. And so we can check. In this case, we're getting values in length, so we can also check by millimeters, or there's also all sorts of kinds of units here. That's also the beauty of our Meadow platform, is everything is unitized, so you don't need to. Sensor will tell you, oh no, give you values from 0 to 1024, and then you have to do some math and calculations to do conversions or anything like that. Just Meadow takes care of all that for you, so that's pretty sweet. So let's actually let's give it millimeters, and we can even change it later if you want. And so we can also check to see, like, if it's less than 0, we can say that it's out of range. Otherwise, we have a range, and it'll print out values in millimeters and in inches at the same time in the console. So yeah. And once you have that event, the question is, like, how can I trigger it? Well, that's where start updating comes in. So when we go into the run method, then initialize everything, you finally call the start updating. And this here, you give a time span, or you give a certain time period that says, throw me fire this updated event. I want it every 250 milliseconds is what this is saying here. You can do it in every hour or every half an hour. You can do all sorts of choose whatever time you want, especially like for things that are temperatures or something. You don't need to check every 250 milliseconds. You can check every half an hour, every 10 minutes if it's a very slow curve of change. So yeah, that's also good. And so if we go now, sorry, getting a message from the chat. Okay. When we do that, and then let's try this out. So I got the distance meter here, and I go to extensions, Linux debugger, build and deploy again. Let's check my output. Okay, it's connecting. Oh, this is all going smoothly. Okay, I still have my camera live. Beautiful. I got a message from Tom S. It says, like, the Raspberry Pi template, it's broken. For Tom, if you're watching, if you're probably your templates might not be updated up to date. So if you do .NET new wilderness install wilderness labs Meadow template, this instruction will uninstall and reinstall the latest version. So if you do that, then it might fix your problem with the template for the Raspberry Pi. So yeah, it's important that you once in a while we need to update our templates. I think we'll make a note of it on our release notes, so we make sure that you're always running on the latest. Okay, so back to here. Upload completed successfully. And now if I go to my terminal here, let's go to CD. Oh, this thing disconnected. Let me go back here. Oh, now we go to CD vs Linux debugger, and then we're going to the distance one, distance meter. Distance meter DLL. So we run that. If we cannot find a project to run. Oh, right. No, I don't need to put the run there. There we go. And there's our distance sensor running. So If I go here and I point, you can see how it changes. I'm putting my hand next to it. I might need a little bit of calibration because I think if I go close enough. But yeah, overall, it seems to work. So yeah, that, like, look at this. Like, this is just like 5 lines of code to get the distance sensor working. It's fascinating. I really like this platform. It's so easy, intuitive to get things working. I also want to give a sidebar here. Like, it's like, well, Meta Foundation is awesome, but how can I find all these sensors? So basically, if we go here to our developer site, we go to Meta Foundation. Here we'll give you a little bit overview about how Meta Foundation works. Is that principle of having a driver, you initialize it, just telling Meta or whatever device to what pins are connected, and you're good to go. You have a beautiful, like, big API, curated API that you can just use, and no more looking in through pins to try to get what's high, what's low to get it to work. It's all done for you. So if we go to peripherals library, here we have a table, a very, very long table of drivers that are already available. So, you have audio, we have all sorts of displays. We have displays of monocolors. We have displays for e-paper displays as well. I have one here. Let me show you. This little guy. You can also use something like this. This is an e-paper display. I was using it for my house to put some information there. There's the e-paper display here. And then if we open any of these, let's open this. Which one? Can't decide. Let's open the radio one, for example. If we click here, it'll tell you. It will give you a few table of data here, status. If it's working, it'll give you links to the GitHub's the source code. Again, Meta Foundation is open source, so you can get to see into the driver's code. We also have access to the data sheet if you want to take a look. And this is the NuGet package. So this is the guide that you will need to add into your projects, so you can start using it. And here we also include some a code example of how to get this to work. And you can take a look at the usage, along with a wire sample here as well. Obviously, it's important to also show you how you can wire this thing. This little one in particular is also an I2C bus. So you just need 4 pins for power, and a clock pin and a data pin, and then you're good to go. And then finally, here's the meat, or the detail breakdown of everything that it has on the API, the driver itself. So if you can go to the peripherals library, there's this huge table, and then here we can take a look. I think it would be cool if we have a search text on top, so we can start. So it's easier to look than all through these. Also, you can do a Control F and look for drivers this way as well. There's the distance sensor. I hope there's this is. I don't know if there's a fritting diagram too. Okay, cool. Yeah, this is good. And there's also the code sample. And these code samples are all auto generated. So on every release, we have a tool that it'll go through all the samples that are Meta Foundation, and they'll spit them out into the documentation. So that way our code snippets will always remain up to date. So you could copy this, you throw it into your application, and you should be good to go. This thing will run 99% of the chance, I guess. So yeah, this is the copy. This is a copy of the sample. Notice it does millimeters here, and it prints out also in inches and reading milliseconds in every 250 milliseconds. So throw the updated. So yeah, I just wire this really quickly. Let's do another one. Let's do something like I'm going to show you the HTU21D, for example. So let me stop this application first. Where is my? Oh, here we go. Control C. Okay. So I can just remove this one. Okay, HTU21D. So let me wire this one up. So I'm going to remove this here. Okay, so let's go here. Okay, some of these jumper wires. Do 33 ground, and then data clock. Okay, so let's see. So 3v3 goes here. Oh, this is the wrong one, actually. I don't need to. Hold on, give me a second. I think I can use this one. I'll put it like this. Okay, yeah, I'm going to use this cable. So I'm going to plug in 3v3 here, and then ground. Ground, I think, is this one. Yep. And then, which one is clock? Clock is the yellow one. Again, I could have used this one. So clock is this one, and data is the blue one. All right, I got HTU21D. Wired up, it's right here. So let's build this one here quickly. Let's do add new project. It's very Pi, and now we do atmospheric monitor, I'll call it. Oh, my music is gone. Let me put this back. There we go. It's like a spa music. All right, so atmospheric monitor, and then I create. Cool. Next step. Now, bear in mind, I'm in this repository. I'm in developer mode, so well, we're in this case. I have project references to all my samples, but let's try just using the NuGet packages. So right here, I have Meadow Foundation, Meadow Linux, but I will need to look for that corresponding NuGet package for the HTU. So if I go back to here, let me see if I can find it here. HTU 1. There we go. Here. Oh boy. Okay. Is there another one here? Oh, I see what. I know what happened there. I need to fix that. It's just that this NuGet package has a family of drivers. So there's the HTU21D, and there's also the 31D. So there's a link with the one that is with the X to encompass both of them, but the link is broken. We'll need to fix that. Okay, so if we go here, then I will need to add this NuGet package. So if I go back to Visual Studio, I go here, I go manage NuGet packages. I do Meadow Foundation. I need to write the whole thing. I'm going to do HCU. This will find it. Oh yeah, this is the one, I think. HCU X1D. Okay, yeah, X1D. Okay. Install the latest. Mhm. I think I already installed it. Okay, yes, it's right here. Perfect. So let's go to the Meadow app class. And always, just for starters, I always like to just copy the sample code and to see if I have wired things properly, and then I can clean this up. So let me copy this. I'll need to do a little bit of tweaking because this code is for the Meadow F7. I'll need to do a little bit of plumbing here extra for the Raspberry Pi. So wait, up to one point did I copy this after run? Okay, make sure that I don't get the whole thing. So I don't want to. I need the public static void main here. Okay, start updating. This is all good. And I just need to pass in one here because again, uh, the Raspberry Pi has several I2Cs. I'm using the I2C one, so it's important that I put that number there. Otherwise, it might not work. And this is another way of using an atmospheric sensor or any sensor that is measuring something. Uh, Normally, the use case is I have a sensor that is monitoring something, and then we're constantly going to be polling, is the reading above a certain threshold? Because if it is, it could be we can send an alarm or we can turn something off or whatever. In this case, we have is observable, create an observer. So we have like an observable pattern, and this way it's another pattern that we have like a filter. So it's this is a this is a subscription that whenever we're starting to monitor a sensor, it's going to monitor inside and look for these values. Like whenever it does a reading, it'll go through the filter region here. And if the sensor reading goes into a certain threshold, then you can return true. And that will call the handler, which will actually do something. So you can set an alarm, you can turn off a heater, or you can turn on an air conditioner, things like that. Otherwise, if this condition on the filter is not fulfilled, you do return false, and this handler method won't be called. So nothing will be turned on, nothing will be turned off, no alarm or anything like that. So you do sensor subscribe, and then you pass in your observable subscription here, uh, and then that's what it'll do for you. The other way is using the updated method. So this one it's guaranteed that this method is going to be called at every time, depending on the time span that you've been giving it to do the monitoring for you. So in this case, we're doing a start updating time term for 1 second. 1 second. So every second is going to call the updated method. Is going to print out these values, but also this is also going to be checked to see if this filter is fulfilled. Then it'll actually call, or this handler code region will start running, and it'll do something. In this case, it's going to just do another output here. So those are two very convenient ways to use the sensor, especially atmospheric sensor. Okay, so we have that. I'm going to set this one as start a project. And first, let's do two extensions via Linux debugger, build and deploy. Check the output. Okay, it's transferring. Upload completed successfully. That's great. And now let's go to developer command prompt. For no, we should leave the universal list here. DB atmospheric should be there. Perfect. And now we do .NET atmospheric. All right. And there we go. So you got initial readings. There is my temperature expressed in Celsius and humidity and percentage. So if I even hold this, temperature change. That's the subscription fee. If the whole pattern, you see that is changing drastically because I held it with my hand, so I'm getting it a little bit hotter. So yeah, it's great. I love when these things work. Okay, cool. So that's another example. See, like it was just less than 20 lines of code, or even less, to get this sensor working, and it's just in a good package away. Oh, it's just it's the best. Um, all right, so let's do that, and I'm going to finally wire a display. Let's see how we do with that. So I'm going to wire this guy. I also need to remember. So again, this is the ILI maybe 341, I think. There's a lot of pins in there, so I'm going to get a cheat sheet of. I made a fritting diagram for this. One. Need that to see where I put things here. Okay, so I'm going to put display here. And there's three, then there's one. Now I need lines. Next. Lines. 1, 2, 2, 3. And then I need another 3 lines, so I'm get more of these. Right, where is my I think I need to make, oh yeah, one is this one goes first, and then the other one. If I skip one, this one goes here, and then there's three. I have them in there. Oh, I have one. It goes here. So it'll look a little janky, but let's use this one. Let's put this one here. 33 again. Put it down here. Go. This thing is already lining up. And let's see. Okay, cool. And then I need another last one. Here. Let's go right here. All right, let's hope I wire all this correctly. Now, what's left is, let's give this a try. All right, so let me go back to, let me go back here. Let's go to, so this is, as I mentioned, this is the ILI 9341. So if I go to the purple library, ILI, that's the display through TSPI, but let's look at the driver itself. Okay. So I will need the Meta Foundation display TFT-SPI NuGet package. So let's do that. Do that first. Manage NuGet packages. I go here, browse, and then I do. This one you can see that there's a ton of more displays that we support here. And this is the one that I have, 9341. Right. Do that. And, let's see, we got that going. So the next thing I am going to let's do this more structure. Let's do I'm gonna do a micro layout thing. So I'm gonna put here a display controller. And then with a display controller do public or receive an pixel display. So display controller, think of it as, it's an abstraction, as a view. So I don't want to have my sensors and my displays all jumbled up in the same class. So that way, if I can have this class that is agnostic of the hardware, I can basically use this anywhere, like right at a Windows or the F7, because basically what it's receiving is an iPixel display. Just give me the display, whatever it is, as long as it implements the interface of iPixel display, and then I'll do all the drawing and everything. So that's what I'm doing here. So if I do that, I'm also going to add another cool framework that we have here, micro layout. Micro layout is my go-to right now to make HMI screens in embeddable devices. So if I go, I'm going to give you a glimpse of how that looks. So if we go here to the documentation, let's go to the last section. And here at Meta Foundation, we have libraries and frameworks. And here we have the micro layout library. So it's our in-house library framework UI library that it's very easy to wire things up. So basically, think of it as you have an absolute layout, and then when you start adding controllers, you need to pass in the X and Y coordinates, which will be on the top left, and then you give a width and height of that control. And that way, it'll just give you, it's like a bounding box that it'll draw on the screen. So in this case, we do a display screen controls, and this is where you start adding the controls. So we have a box and a label in this case that has a hello world, and a box that is red, and half, or yeah, so half width, half height. So it's going to be a quarter to the display. So when you run it, you'll have something like this. And that way, if you declare the label to be local, you can just do label.text, and at runtime, when you change that value of the text, it'll just start updating the label right away. Whereas if you did it on micro graphics, you need to actually draw a rectangle in a code region where that label is to erase what the value had in it. Draw. That was not ideal. I'd rather have more controls. So we have controls for for a box or a circle as well. And here's our famous label that we can pass into fonts, colors, background as well. We have pictures, so if you add bitmaps into your application, you can also draw them. And we have, this one's really nice. We have a line chart. So this one will just give a list of points or readings of your sensors, and you give some parameters here on the chart. And this one's the newest control that we had is a progress bar. So I use this for OT over the air updates with Metal Cloud. So when we do a project lab, then you can see a progress bar going, progressing to keep an eye on what the application is updating. And finally, I think we have, oh yeah, we have our buttons as well. And these buttons, I think, are already implemented to handle the screen as well. So if you run this on Windows and you have has a touchscreen, you touch on the display. And here's a final example of it. Cool. That was a quick. So let's go back to here, and I'm going to steal some code from whether app I have something similar like that. Controller. Uh, I'll make a label. And then and we can do is color add meadow here. Use our colors, and then for that we do is display screen controls. And here we have a label. New label. And we need to pass the coordinates. So go now the display screen. Okay. Yeah. I want to my display. Right, so I do that, and place here. Now, color with font. So we have several fonts that we can use. 12 by 20. But we don't have scale. So if you have high res displays, fonts that are just 12 by 20 might just look very small still. So we also have a multiplier to scale a font. So let's start with scale factor 2. And we also have aligns, horizontal alignment. Why do we have alignment? Well, because in this case, I'm doing a label that is going to cover the entire screen of the display. So there's plenty, like that control is plenty of room to move around. So that way we can establish the bounding point. We can do horizontal alignment and vertical to center, and then microlayer will just move the text itself. You know, line. So if I want it centered in the display. So that's why it's here. So once I do that, it should work. Let me try. Well, it's better to initialize this. I'm also going to select this is the code to initialize. that. And notification displays. And so here I'm doing my so basically here, we're doing is we're creating an SPI bus on the Raspberry Pi. So it has we also specify the frequency for the bus as well. So the frequency of 40 megahertz. And then this is the actual initializing of the display. And we pass in this here. And then at the same time, we add these extra pins, the chip select, the DC, and the reset pin, along with the resolution of the display. It could be that some displays have different form factors, so they might come with different resolutions. So this one is 240 by 320. And oh, right, very important. I need to actually declare my display screen. Actually, display controller. Display controller, new display. Display controller. And then that will go into the micro layout. It's going to draw the red box, red image with a hello or happy piping. Let's see if this works. So I do this, and now I go back to extension, and debugger, built and deploy. And then here now I do. I wired it correctly. Oh my god. Okay, cool. So yeah, check this out. So I go here, so layout, so so yeah, so we're doing two-factor. So let's do one more thing. Yeah, thank you, Trey. Yeah, oh man, I practice this quite a lot. So let's go to. I'm going to show you now. Is let's print out the temperature and humidity onto the display, and then I think we can wrap this up. But again, thank you so much for everybody who's more than an hour. Let's get this going. So in this case, I will need to do label, temperature, and then I do, I'm going to move, and then that way, if I have the object with the temperature, I can come here and I just but now I still have my object that I can use later on to refresh the and we need to do some tweaking about the bounding box because temperature label right now is taking up the entire screen. So I can do that without because it will draw one top of the other. Mm-hmm. And let's put here. No, nothing degree symbol here. And then your for your bounding box, I will off the half display, and then and then it'll take out the other temperature here, and then over there, here, right? Um, ah, label and I don't need them. Okay, got my display controller. Yeah, let's do it here. So in the updated display controller update, and then here I pass in my temperatures. This one would be actually I can grab this whole thing. Sure, let's grab this whole thing. Why not? And I'll need to make it shorter because I might leave. I might get off the screen. Just call this one. Humidity and temperature will be enough. We'll see. So this, okay. So what have we done? We updated this display controller. We added two labels, one for temperature, one for humidity. Temperature will be on the upper half of the screen, humidity on the lower half. And we're adding them into the controls. And then we exposed a public method update, which takes two strings, one for the temperature, one the humidity, and then we'll reassign the text property on the label with those new values. And so we'll see it changing. We'll see it changing every second. So we wired the display controller update method here with the updated event. So this thing will be called every second, and at the same time it prints, we should see something on the screen. Let's see if this works. So let's go extension, Linux debugger, build and deploy. Did it do it? All right, that was quick. Okay. And then I go here, stop this. No truth. Uh-huh. Okay, we got something, but that's not what I want. Let's see. I got something wrong here. Display controller. Oh, I see what I did wrong. This is the wrong place. This is 0, and this is the y coordinates. This is where I want it to be. Okay, let's try again. See how fast this is? One change, build and deploy. This goes out through the network. It's already done. Command prompt, stop this. Try it again. There we go. It's leaving the screen. I can actually make it smaller than we'll just make T and so I don't want it to make like this. And then once again, 2 extensions. SSH connected, compressing, upload completed, perfect. We go back here, Control C to stop the app. And there we go. Now let's do solo layout here so you can see it. So there it is. You can see how this is kind of changing, but if I hold the sensor with my hand, you can see how the numbers, they go up. Yeah, exactly, Trey. Trey is saying, that's great. You can push a new code while it's being used. No need to stop running before pushing new code. Yes. No, this is, when I learned about VS Linux Debugger, this is lifesaver of changing. Like it's much easier working on Raspberry Pi this way. At my starts, I'm also a super Raspberry Pi newbie, so I was using the Raspberry Pi remoting in and trying that, but sometimes my Wi-Fi is a little unstable, so sometimes it loses connection. So no, this is way better than just remoting in and coding inside the little thing. So yeah, so there you have it. I gave you a little bit of rundown or several project samples on how to use Meadow on Raspberry Pi. I hope you learned something. I think these recordings will be around for a while if you want to take a look, or if maybe somebody didn't catch it. You can see it, and yeah, you can follow along, or feel free to ask us any questions. The published Slack is it's available for everybody. So I think we have 1,000 people over there. So if you haven't, you can join, and you can also find us the published Slack. I think it's in here somewhere at the bottom. I lost where it was. Oh yeah, I think. Where's the Slack? Oh, I think I know where I can do it. If you go to, you can go to this. Go to our repo here. Well, we'll share it on our socials to join our published Slack. If you want to have any questions or anything like that, here we go. I'll also put it here on our chat. Copy link. Oh, there you go. Joshimori. Thank you, Joshi, Chris, to share that. So yeah, go to slash.whatsapp.co. You can join us, and yeah, if you have any following up questions or any questions in general with Meadow and Raspberry Pi or any other matter, just throw us a message there and we'll help you out. Thank you so much to everybody who joined. I'm really happy that this all worked out. And yeah, happy Pi Day, which is funny because my wife actually brought me a slice of pie that I'm going to have to eat after this. So just sticking to the theme. So yeah, thank you so much. And we'll talk soon. Have a good one. Goodbye.